Hello everybody, my name is Elsa and I'm here to welcome you to this short series about citizen science and the Dive-In project. Today we have a special guest here, Gaspard from Gluon, and during this episode we're gonna talk about electronical programming for youngsters. So thank you so much, Gaspard, for being here, and please, can you tell us something more about you and about your organization?
Yes, thank you, Elsa, for having me. It's always a pleasure to be here. I talk about Gluon a little bit. We are actually a non-profit organization that's based in Brussels in Belgium, but we work on European projects as well. And we focus on three things, the first being science, as well as technology and arts. We do this because when you combine those three, or at least people in those three subjects, it can sometimes lead to very innovative and cool projects or ideas. And we think it's very important that we combine it because it can lead to very critical thinking that can improve our society, and we should always ask ourselves the right questions when it comes to those subjects.
Of course, sounds great.
Yeah, and we do this in two ways. The first being with Gluon Art and Research, we facilitate artistic residencies for European or Belgian open calls. And during these open calls, the artists can propose certain projects, and we as Gluon evaluate them, and we select certain projects that we want to bring to life. And what we do for those projects is we bring the artists in contact with the right technological suppliers or the right scientific researchers to give a better understanding of the subject, so that the artist can then make a project on itself in that subject. We then also apply the same methodology with Gluon Education, which is what I do. I work for Gluon Education, and we try and combine art, science, and technology through workshops or other extracurricular activities. We do this both in formal and informal education. So informal, we really sit together with the teachers at schools in order to bring these new technologies, the science, as well as the artistic views to the classroom. And we do this through formats of workshops. It can take 1 day, 1 hour, sometimes it's more than that. And we really try and push the boundaries of the technology and the science behind it to promote as well this aspect of science and technology. Because sometimes, nowadays at least, technology is evolving very rapidly. And it can be very challenging for certain teachers and educators to grasp this and to also give it to the youngsters. So this is where Gluon comes in, and we try and bring curriculated content to the teachers, and we sit together with them in order to inform them about these new technologies that are available, because it's more and more accessible, and also to have a good understanding of it so that they can give it to the youngsters, and that the youngsters can go about with these technologies in a creative way, but also in a very critical way. It's important that we educate now in order to have the next generation of scientists and everything like that. So that's where Gluon, we try and find the educational content to bring to the schools. Outside of schools, we also do extracurricular activities. We call them camps or labs, where like for 1 week we sit together with an artist and a team of youngsters, and they all do their own little projects.
Wow.
And it can lead to some very cool stuff. And we do the same thing that we do with artistic residencies, kind of. We teach them a little bit about the technology. We bring them to places where they can learn about it, and then they come up with their own questioning, and they create their own projects. And the idea is that in 1 week, so it's very, very fast always, they make their own projects, and they present their projects at the end of the week. It's important that they are in the spotlight at that moment, because they have to own their own projects and stand behind it, so that they can be proud creators and that they can keep creating later on as well. We always try to do a little expo or something like that, where they get to be in the spotlight.
I think it's really interesting, this kind of new approach, also to teach to the teachers how to teach new things and technological things that are a lot of times really difficult for the most of the people. So I think it's really good. And this kind of new approach bring us to talk about this kind of new concept that is citizen science. So let me ask you, what is the citizen science for you and for your organization?
Yeah, so citizen science is really interesting. Nowadays it's become science in itself, which might have been very inaccessible, is becoming more and more accessible also through citizen science. And what do we mean with citizen science? It's involving citizens or people who might not be with a scientific background in the research behind certain subjects. So the biggest example that we use is if, for example, every citizen can have access to a thermometer that is connected to a network, and we evaluate the data, and the data comes in, and everyone can understand or can look at it and can understand something from it. So the idea is that with citizen science, we bring the science more accessible, and we let the citizens participate in the research behind it. And this can lead to a lot of data, because for science it's important that you have data in itself to evaluate and to make decisions about it. And with the citizens, there's a lot of them, so you can hopefully use a lot of citizens that are participating in citizen science in order to, in a shorter time, have a lot more data to register. And you can do this with projects, but we do this also in workshops at schools or stuff like that, in order to already involve youngsters already from a young age with science as much as possible.
It's really interesting. Yeah, so it's both useful for scientists and useful at the same time for the citizens. Yeah. They help each other to make this world a bit better, let's say.
Exactly.
I love it. I love it. I love it for sure. Can I ask you something more about maybe your projects? What do you carry out to involve people in Gluon with your projects?
Mm-hmm. So yeah, we do workshops in the schools, and one of them is a very practical one where we do data measurement as well as data visualization. So with that workshop, we let youngsters build their own little sensor in order to measure data. So because these technologies are becoming more accessible, you might not find the right tools immediately, so we show them kind of what you can use to make your own data measurement stuff. And with electronical programming, you can then very easily already register certain data. If you have the right equipment, you can easily find open source documentation, which is free and accessible to everyone, that has internet connection. And with that programming, you can easily already measure a lot of data. And with that data, you can then visualize it, and that will result in more and more inputs for citizen science.
That sounds really interesting. I'm really curious about it, so we'll go back to it. Yeah. But I would like to ask you something more about you, actually. How did you become passionate about science? If you remember the moment or the people, the person who let you be more passionate about science?
Mm-hmm. Yeah, for me, I have a background. I don't have a specific background in science, but when I was arriving to university, I got into contact with the Fab Labs, or the maker spaces, as you also call them. Okay. And I was very passionate about 3D printing at the time, because it seemed so cool and new to make an object out of nothing, basically, or out of something recycled, and you just program the object itself, which at the time seemed super futuristic. Yes. And for me, that was really where my eyes opened up, because what seemed to me as something very inaccessible suddenly became super accessible. And I went to the Fab Lab, which is a place where you have access to these machines and technologies and people who actually are there to help you out and to teach you how to use them. And for me, it was nice to see that it was a great exchange, because you come there to learn how to use these machines, but you can also come there to make your own projects, and you will it's a shared space, so you can go there and help out others who are working on their own individual projects. So everyone is doing their own little thing, but still you are using the same machines and people are sharing their knowledge. And what was really the most learnful out of that experience was that it was so okay to make mistakes. When you make something, 99% of the time it will not work first try. So the idea that you make mistakes that you can learn from is really gratifying.
That's really amazing, actually. So this kind of Fab Lab, you also cooperate with them with these kind of spaces, right?
Yes, yeah. With our organization Gluon, we try and work together with them because these technologies, okay, I say they are accessible through the Fab Lab, but as organizations or individuals, they can still be very pricey sometimes. So this is where the Fab Labs come in. They invest in materials, and we try and come back to the Fab Labs. We try and make stuff with them, and to also teach, train youngsters, for example, to learn these new technologies, to come into the Fab Labs and to learn these technologies. And we then promote these Fab Labs because it's a wonderful place for people who want to come and make whatever they want to make.
Yes, that sounds cool, and I think it's really good also for the social point of view. You make your own community, you build a network really of people that care about it and really dream about these kind of places to share knowledge and good practices. I think that's nice. So can I ask you to show maybe us a bit of your tools, technological tools?
Yeah, so I brought some stuff with me today. Like I said, we have a workshop at Gluon where we do data measurement and data visualization, and we do this with electronical components. The most common one we use is Arduino, which is a programming tool that is also open sourced, and you can find them, and they're very accessible. Today we are using a little bit different tool. We are using a Raspberry Pi. And this is a small computer, basically. What you would usually have as a desk and connected to, let's say, a screen, a mouse, and a keyboard. This is basically the same thing. You can add more stuff to it with these little pins. You can add a little sensor that can measure, for example, the temperature or the humidity, and you can easily program this. This is all very open source, so you can find the documentation of it online. And this kind of computer, it costs around 40 euros. So for a computer, that's very inexpensive. So the idea behind the workshop is that we teach them step by step, what is this Raspberry Pi or Arduino, or they come in all different shapes and sizes, but each with their different means. And we try and show them how to use them. So you can find the documentation online, but sometimes that's still a bit intimidating, where to start with all of this. So we show them how to measure data just simply by attaching a sensor physically to this. And then they see the data coming in through a script of code that we wrote already for them. We then push them to edit the code a little bit to teach them about programming itself. Nowadays, because programming used to be very intimidating for a lot of people, there are a lot of tools now online to help you teach coding and programming online as well. So we do this workshop where they first get a grasp of measuring the data, and they do this physically in the classroom with these Raspberry Pis. And then we look at the data that they measured, and we try and visualize this on the screen or through creative means. There's the second part where we focus more on the visualization, because obviously the more creatively you can visualize something, sometimes it helps in promoting or to help in the scientific research, but to actually promote the science behind it. It can be cool if it's visually pleasing, or it's just cool in a way, looking differently than just regular data in a table.
It makes
sometimes
it even easier.
Exactly. Also less boring, maybe. It's a bit of a cool ways to visualize it. And then we also look at another sensor that we already pre-install at the school, because if you measure data, it takes a lot of time to measure a lot of data. This is also where citizen science plays such a nice role, because you can immediately get a lot of data. So what we do for the workshop is also we look at data that we already registered. So we try and place sensors through the city in the specific schools that we teach the workshops in. And these sensors, they measure not only the temperature and the humidity, but also the air quality and fine particles that are in the air. And they visualize this on an open source website where you can find all these sensors and all these data sets so that they can actually have a look at bigger sets of data and get already more an understanding of what they're looking at, because if you look at one specific time, it's not as informative as when you look at a complete different set of data. So
and you also collect your own, let's say, city data, your own environment. I think that you will be more connected even with your environment. So it's really useful. Say it in this way. I think it works perfectly. More citizen science, please.
Exactly.
So Gaspard, can you show us what did you bring with you today?
Yes, gladly. I brought a little bit of stuff with me, some electrical programming tools that we use during the workshop. I brought two with me because there are a lot of different formats and ones that we use. Most common one is Arduino, like I said, but here with me today I have a Raspberry Pi, which is a different variation, but it has the same functionalities. The idea is that you can program these with very easy, accessible open source documentation. During our first workshop, what we do with the youngsters to visualize data, you have to measure it, and we teach them how to install and make their own little sensor. And this is one of those sensors. It's temperature and humidity sensor. The idea is that they get a manual that explains them how to connect it to the Raspberry Pi and how to visualize some of the data. So I say, let's try it out. Let's try it out. So the first step is actually to manually install it on the Raspberry Pi board, which has all these 40 different pins. If you do so correctly, you will find that it will monitor the data through a little programming, some code that we already pre-made. So the first part is to actually manually put the cables on in the right positions. Every pin has a different meaning or different functionality. And I know them by heart, but usually you have to follow a little documentation that can tell you which pin exactly does what. Usually for an electrical circuit, you always need a current that goes in and a current that goes out. And here we use 3 different cables. So one is for the current to go in and one for the current to go out. And then the third one is to measure the data. So what kind of collect
Great.
So once we have this connected, we also connect it to our computer. You can connect it through internet, or you can just actually put a screen and a mouse and a keyboard.
Perfect.
We are here today. We're using a program called PuTTY and VNC Viewer in order to basically, you can kind of hack into the computer because it is a small computer.
Of course.
And we have a login. After which we can view what the Raspberry Pi is seeing on the screen. Let's have a look at it. So this is a virtual computer. We are now working on the Raspberry Pi. And you can see that there is one document, it's a script, a Python script, which has all the code in order to visualize what this little sensor is measuring. So if we run that program, if we install it correctly, then you can see some temperature data and some humidity data coming in. Right now, it's not too warm. It's a bit cold. We're 14 degrees, and it's a bit humid. Also, because I'm holding it, you can see that it influences the data as well.
Perfect.
So this is something that we always ask in a questionnaire to the youngsters, like what can you measure with this kind of stuff? How can you influence the data, and how do we collect correct data? Because it's important that they realize what they're doing in a correct way, and that they can think critically about what they're measuring. So this is the first part of the workshop where you do some theoretical aspect. Of course, like you can see, it still comes in very slowly, the data, and we want to have a look at a lot of data. This is where the sensor that we set up at the schools comes in, because we installed it like a week before.
Perfect.
So it has all the time to collect a lot of data, which is a bit more interesting to look at, which we can have a look as well. We use a sensor called Smart Citizen, which are developed in Barcelona. It's also open source.
Okay.
And you can find a lot of sensors on their website. It's a platform with a map, so you can look at specific locations that have these different sensors. And you can see that it's not only collecting temperature and humidity, but also light levels, noise, but more interestingly, the air quality, and also fine particles that are in the air, in order to give a view about if the air quality today, if there is a lot of smog or bad stuff in the air. It can help make decisions for schools. So, for example, open the windows if you put it in a classroom and you notice that the CO2 is going up, for example.
Of course, to understand the pollution of your city.
Yeah. Also for COVID, when we are not allowed too many, it was important that there was a lot of air and not too much CO2 in the room. So this is also something where these tools can come in handy. I have a second part with me today that's also a bit more accessible, that makes use of visual coding. And for this we use M5 Flow, which is a website online. And we can add codes from directories that we find online, or you can load some examples. Right now I have one small one prepared. I brought with me what's called M5 Stick, and it's this little red box which has a button and a screen. You can simply attach it to power it to the computer, or you can do it without even. And it's connected to the internet. It's called ESP32, and you can find a lot more documentation of it online. So what I just did is I added this little hat, which is called a PIR hat. It's basically just a tool that sees if there is someone passing by, so a motion sensor, as we would say. And I added also this little LED strip. These are just 10 little lights that you can program. So the idea is to give people an understanding of what is coding, what is a little program that you can make very easily. The idea would be that you can use the motion sensor to turn on or off the lights. Cool. If it were written in Python, then it does the conversion on its own, so you can see both types of coding, kind of.
You know, now I get it, how it make it easier to see with colors.
Exactly,
for sure.
Yeah. This is a bit more accessible also for younger ages. So once we do that and we program the code in here, we can then run the program, and it should upload to the M5 stick, which we can then disconnect. And if we wait long enough, we should see that the motion sensor does not detect anyone, and it should turn on the lights, as you can see here. Yeah. And if we pass in front of it, the lights turn off. Again, there's a little timer in between that shows when it turns off. Now it doesn't detect anyone, and if we pass in front of it again, then it turns back off. So it's a very simple, very little experiment that we try, but there are tons and like millions of possibilities that you can do with these little attachments. They're very easy to and they're very inexpensive.
Yeah. So how much does it cost, for example?
So this little computer, because it's also a small computer, it costs around 15 euros. And these little attachments, you can get them very, very cheap, ranging from a few cents to 1 or 2 euros. So.
Yeah. So actually, some of them are cheaper than the toys.
Exactly.
Other tools that
and
we can use.
And they're fun toys to play with.
That's amazing.
You can make your own little toys that are moving.
Useful toys.
Yeah, exactly. And then it can get very intricate. You can connect this to different systems and networks to collect data. And you can make very intricate designs that also help with citizen science and collect data online very efficiently. So these are easy to learn and hard to master, as we call them. You can really continue working with them and add to the documentation. Some parts might not have certain documentation, and you can definitely add it yourself in this open source type of programming.
Yeah.
But you can really do little creative projects with it.
So
and it's something that we use a lot for prototyping.
Yeah.
Because you can make one-on-one the little prototypes with just a few tools, and it's done in matter of seconds. So.
Yeah, I can really imagine how many options the children or the youngsters have in front of them just with these little and cheap tools. That sounds really, really interesting. I will think about plants, soils, a lot of other index that we can focus on.
Yeah, some cool projects that we did with this was, for example, a soil sensor.
Okay.
Where it sees if it's humid or not, and if it's not, then it adds water through a pump automated system. So it's really cool to make some home DIY projects as well. Yeah.
Well, I would be really an happy girl to have it. So
well, we will leave this with you.
Thank you so much.
Continue working on it.
I really appreciate this show, really. Thank you. So Gaspard, thank you so much for showing us your tools. I'm gonna ask you the last question, but it's really important for me to ask you this. So what do you think will be the future for the citizen science and with citizen science?
So I really hope, at least, that citizen science can become more and more accessible for everyone, so that everyone can participate as much as possible, and that people will actually do it. But I think in order to do so, there are a couple of things that can be helped. First being that organizations such as Gluon, Punto Zero, and all the other organizations that are working on citizen science, that they have the tools at disposal and that they are also promoted with the correct networks. If all the people that are involved with science also promote it towards people who don't have a background in science and try and make stuff that they are already making more and more accessible, then I think everyone can benefit from it. And that's where everyone can finally have a role within this picture of citizen science, one that can be heard for everyone. And as well that countries, cities, and municipalities even help promote these organizations, and other schools have an impact on that as well, so that everyone plays together, so that we can really create those local expert groups that will help with citizen science and promoting science in general. And I think if we get there one day, that would be really beautiful.
Thank you so much. I really agree with your point of view. So thank you so much again, Gaspard, for being here and to let us know a bit more about your topic. So thank you, and thanks, Gluon.
Thank you, Elsa.
I hope we will see each other really soon. Thank you, and we hope it's gonna be really interesting also for you to be more focused about this new concept of citizen science. So thank you so much.